Hi all, welcome to the channel N to D, number to decision. When it comes to life, decision plays a crucial role. Same way, when it is coming for business, decisions are very crucial. Every part we should be very careful when we make decisions. Through operations research, we are going to see today how we are going to make decisions. So when you look at operation research, there are plenty of concepts that way we can use it in order to take decisions. So today's concept, what we are going to discuss is transportation model. So transportation model is one special type of linear programming problems, so which is used to optimize or minimize the transportation cost. So every organizations or the industries which uses transportation, so it is very crucial for any organization to minimize the cost of transportation. Let us look at how we are going to use this transportation problems. So as I told you, it is a linear programming problem which is going to find out an optimum solution for transportation and allocating resources to various destinations and from one side to another while keeping the expenditure to a minimum. So when we look at on the right side, we could see like there are factories and there are warehouses. So here from the factories we have to transport goods to the warehouse. So we need to find out what is the best source to the destination, that is from which factory we can transport goods to which warehouse, so that the cost of transportation is going to be very less. So that is what the basic objective of your transportation problem. So it involves two things. One is the source and the destination. The source is nothing but the factory and the destination is your warehouse. So here we denote source as M, okay, and the destination as N. And here we are going with certain assumptions. So the assumption first, which is supply level of each sources and demands at each destination are known. So the assumption is very clear. We are assuming that supply and the demand is known. So then only we can proceed with these problems. And the major objective here is to minimize the total transportation cost. And in transportation problem, the answer should be always non-degenerated. Let us look at what is non-degenerated initial basic feasible solution. As I told you, m plus n minus 1, which is equals to number of allocation, which means that it is non-degenerated. So in the previous slide, we looked at what is m. M is the source and n is the destination. So otherwise, m is the row and n is the number of columns. So m plus n minus 1, which is equals to total number of allocation, then the solution is what we call it as non-degenerated initial basic feasible solution. In case if m plus n minus 1, which is not equal to total number of allocation, which means that it is a degenerated initial basic feasible solution. So always we should have a non-degenerated initial basic feasible solution. And when you look at transportation problems, there are multiple ways in which we can use it. There are multiple methods. The first method is what we are going to see for today's session is northwest corner rule. So let us dive deep into it. So here, as I told you, on the first column you have the origin, so that is O1 to O4, and the first row we have the destination, which is D1 to D3, and their respective cost are given here. Okay, and we have the demand, which is 7, 9 and 18, and supply, which is 5, 8 and 14. So first thing is we need to look at whether the problem is balanced or not. So let us first confirm whether the problem is balanced or not. How we are going to check whether the problem is balanced or not is we are going to summate the total supply and the demand. When these two are equal, then the problem is said to be balanced. So let us find out the summation. So 5 plus 8 plus 7 plus 14, which is equals to 34. And the same way demand 7 plus 9 plus 18, which is equals to 34. So now these two are equal, then the problem is said to be balanced. So here the method what we are going to see is the northwest corner. So let us look at the map here. So this is the north and this is the south, and we have the northwest here. Okay, so always we have to look at the allocation starts from the northwest corner of the table. So this is our table value. So in which we are going to allocate only in the northwest corner. Okay. So here, what is the northwest corner? When we look at the cost, which is 2, that is origin 1 to destination 1. So that is the northwest corner. So let us start allocating. So we'll start allocation from the cost 2. Okay, so let us look at what is the demand. The demand is 7 and the supply is 5. That means I want 7, but the supply is only 5. So I can get only what is in the supply. So I'll get only 5. So the entire supply got over. So I need to cross out the entire row. And what happens to the demand? I have already got 5. So the remaining is going to be 2. And the next one is we have to look at what is the next northwest. So the next northwest is 3. Okay, so at 3 we have to do the allocation. So what is the demand? Demand is 2 and the supply is 8. So only we can allocate 2. So the entire demand got over. So I'll cross out the entire demand and the supply remains as 6. So now let us look at what is the next northwest. So the next northwest is 3. So where we will allocate, we have supply as 6 and demand as 9. So how much we can allocate? We can allocate only 6. So the entire supply got over. So I'll cross out the row and the remaining demand is going to be 3. So now, which is the next northwest corner? So the next northwest corner is 4. So let us look at the demand. Demand is 3 and the supply is 7. So how much we can allocate? We can allocate only 3. I'll cross out the entire demand and so that the entire column gets cancelled. And the supply remains as 4. So the supply remains as 4. So now let us look at what is the next northwest. The next northwest is 7. So wherein the supply is 4 and the demand is 18. So that I can allocate only 4 here. The entire supply got over and the demand remains as 14. So finally we have only one cell which is 2. So we have equal demand and supply. So we will allocate that in the cost which is having 2. So now let us check whether the problem is degenerated or non-degenerated. So how we are going to find out degenerated or non-degenerated is we will use m plus n minus 1, which is equals to number of allocation. So how we will find out m is nothing but the total number of rows. So we have 4 rows and we have 3 columns minus 1, which means that it is going to be 6. So now let us count how many number of allocations we have. 1, 2, 3, 4, 5 and 6. So we have totally 6 allocations. So both the set of conditions are true. So now the solution is non degenerated. Okay, so now let us find out what is the total transportation cost. So transportation cost, how we are going to find out is the number of allocation multiplied with the cost. So 5 into 2 plus 2 into 3 plus 6 into 3 plus 3 into 4 plus 7 into 4 plus 2 into 14. So we have all the 6 allocations. So the total value is 102. So the total transportation cost is 102 and the solution is non-degenerated basic feasible solution. I hope you understood how to solve a problem by using northwest corner rule, and thank you for watching the session. We'll meet with another video in the next session. See you until then. Bye from Santosh.